Thank you very much. Okay then, yeah, so good afternoon everybody. Thank you again for joining. Apologies for the technical issue. So yes, what I would like to talk to you about today is CERTUS, and particularly talk about the elements around reducing the cost of HAV and ADAS verification and validation efforts. So I'm going to immediately cheat and introduce the topic with a video, which can be far more concise than I can right now. So hopefully the audio will work, and we'll see.
Automated driving systems development is hard, with vast verification and validation efforts required prior to commercial deployment.
CERTUS improves testing efficiency by enabling developers to answer three key questions: what to test, how to test, and when to stop testing. By helping to answer these three questions, it's possible to reduce the cost and time to market. Currently in industry, we're seeing a real preference for data acquisition through mileage accumulation. CERTUS is looking to supplement that approach by taking existing data and understanding the areas that have the greatest uncertainty, allowing developers to most efficiently target those areas requiring further development. When it comes to how to test, it's really critical that we pick the right test modality for the right test case. Whether we're looking at the physical, simulated, or mixed reality domain, we need to ensure that we're achieving validity across the entire test program. To understand when to stop, we need to consider two core components. Firstly, we're developing oracles to combine different metrics as well as providing contextual insights into a given system. This allows us to improve the efficiency of the V&V process and more efficiently ascertain where those areas are that developers need to focus their efforts on improving their system. Secondly, we need to quantify the risk to help our customers make an informed decision about the safety and the readiness of their system for a commercial deployment.
Project CERTUS's innovative approach positions the UK as the key global destination for autonomous vehicle testing.
I won't admit how many takes that took, but we'll just assume that it was one and done. Yes, okay, so it'd be great obviously to talk about everything in CERTUS today, but for the sake of time, I'm just going to focus on a couple of key areas. So one of the big topics that I mentioned in that video was the idea of testing across multiple different test modalities, or in other words, multi-pillar testing. So at the top of the hierarchy, we might expect to see public road testing, so mileage accumulation, which of course is great, very important, but equally very expensive. So if we want to improve the efficiency and reduce the effort and reduce the cost of this process, then that means it's really important to look at other alternative ways to supplement that approach, thus reducing the number of miles that we might need to perform in order to establish our safety case. So at the opposite end of the spectrum, we can see simulation, in particular talking about model-in-the-loop simulation there, which, again, this has its place in the sense that it's much, much cheaper, it's easier to perform complex, potentially dangerous tests, but we have to acknowledge that it's quite far removed from mileage accumulation. So to bridge those two worlds, we have physical testing on proving grounds, so nothing particularly new or original there. But we also have developed in CERTUS mixed reality as well. So alongside this hierarchy, we have a couple of other tools and technologies that we use to support the process. So those include search space optimization, oracles, and quantifying risk. So again, I'm going to need to just focus in a couple of those areas today. So to begin with, I'm going to touch on model-in-the-loop simulation alongside search space optimization, and then after that, I'll touch on the mixed reality elements. Okay. Great. Okay, so in a nutshell, what you're looking at here at the moment on the screen is car maker on the left and our model, or our stand-in system under test, Apollo, from Baidu on the right. So car maker is taking responsibility for taking a high-fidelity environment. This is actually taken from a point cloud scan of our proving ground, and it's able to take that, it's able to simulate sensors, it's able to simulate output from those sensors, and then feed them into Apollo in this case, so our model in the loop, as if it was real camera input from physical cameras. At that point, Apollo is able to ingest, make decisions, and ultimately return actuation commands back. And then CarMaker is able to take those commands and able to apply them to the dynamics model, and thus you get a moving vehicle. So you put it all together and you get this co-simulation that's testing the model itself to the best ability that I think we probably can achieve within simulation. So I might just skip through quickly just to explain a little bit more about the other concept, which is search-based optimization. So to be clear, whilst you can see that in this video I'm fiddling about with the visualization window, just to make it a bit easier to see, to be clear, what you're not looking at is a predefined set of tests. Rather, this is an automated test program. So that means that the search-based optimization tool that we have in play here is able to run tests, observe the results of those tests, and then select new tests based on the previous recorded performance. So this is helping save effort because we're able to really focus in and identify that pass-fail line more efficiently. Okay, so moving on, I'm going to just jump straight over this slide, but I just wanted to flash it up to give you an example of how we can build up a model overall to characterize a problem space from following this approach. Okay, so I'll move on to mixed reality. So you saw this in the video, so I've just taken a still to explain it a little bit more. What you're seeing is some of our vehicles performing a scenario, a physical scenario, and you can see on the screen on the bottom that we've also captured that all these positions, this data, is being fed in real time into CarMaker. So this is where the mixed reality domain comes into play. So that's quite useful into itself, but eagle-eyed viewers may have noticed that whilst we can see, in this case, our system under test, and we can see our test vehicles, which are fully automated, by the way, you may have noticed that there's a vehicle in the CarMaker simulation that we don't see present in the physical domain. So this is the really important part, that in CarMaker we're able to create that simulated vehicle, but looking at our two test vehicles in the middle of the junction, from their perspective, they perceive that vehicle in the physical domain as though it was really there, and it will react to it as is appropriate. So that is how we're able to start bridging those two different modalities. So why is that important? Why is that powerful? As I've already alluded to, it's really useful because it helps us bridge that divide between the simulated world and the totally physical world. Why that's useful? Well, you can sort of imagine that there are lots of different complex physical tests that we might want to do, and those tests could be very difficult to set up, to repeat. You might have very nuanced conditions involved. When this vehicle gets to this point, I need my other vehicle to trigger. That can be really hard to do repeatedly within purely physical test. So this can help with that. The other side to it is that sometimes you might actually just have a test that is very safety critical, that is very hazardous, and thus, if you're doing your due diligence, you need to take appropriate mitigations for that risk, which is expensive, timely. So again, through doing this, you can get a better understanding of your system under test first, because you can see how it reacts to a vehicle that it thinks is real, and then you can use that information to decide how you go forward in terms of your purely physical tests later. And again, ultimately, this is all about reducing effort and allowing you to accelerate your program and reduce the cost and time to market. So with that, I'm finished up and happy with some questions.
Perfect time again. Thank you, Will.
No problem.
We've got a question from the audience. There's a microphone coming.
Hi,
Hi.
Nancy here. I wanted to ask about your model. In terms of its reliability, how reliable it is in terms of like the percentage that you've able to achieve, and how far along you are, or how much further you need to go?
Sure. So in terms of how reliable that specific model is?
Yes.
Yeah, okay. So that particular model, happy to just flash it back up for a second, the example. There we are. So in this particular model, what you can see is that we have different regions of confidence. So we have an overall confidence rating, but we also have local confidence ratings. And this is basically a cross-validation approach. So we're identifying the forecast quality and accuracy of the model, and we're doing a large volume of tests to be able to do that. So in this particular example, and there's a whole another layer to this that I'd love to go through, but obviously don't have the time for. But what's really interesting here is that as you start to break down this model and you see regions with low confidence, that indicates something else is going on. And that is what allows you to go, right, okay, this is an area that I need to focus in on. This is part of the problem space that's an issue. So that's going to aid me as a developer to say, okay, this is the area that I need to debug, help me understand what's going wrong, and then ultimately fix that issue. So does that answer the question, or have I slightly gone around it?
Slightly gone around it.
Slightly gone around it, yeah.
I guess from what I'm looking at is, are you at the point where you're able to move to the next phase, or you're still looking into creating more scenarios and cases? I mean, you're always going to be creating scenarios to develop it, but like in terms of next phases and, you know, next goals or objectives to your model, sure, how you're going with that?
Sure, I see, and that's fair enough. So I should probably take a bit of a step back, bit of context. So from our perspective, we are not focusing on producing the system under test. Our goal is to create the platform and create the service and the framework within CERTUS to enable and help people who are developing ADAS systems and highly automated vehicles to support them. So really what this is a real example, but our interest is less in saying, okay, we want to get this system under test working. In this particular demo, what we want to do and show is that we have the ability to take a vehicle from a customer, expose it to a library of scenarios, just like you're describing, provide this information for their use, and then work with them to help them get on top of any issues that reveal through this process. Hopefully that answers a bit more directly. Yeah.
Thank you very much.
No worries.
Thank you. We can probably squeeze just one more question.
Thank you. David Evans, WMG. Thank you for the presentation first. I'm interested in the boundaries between the different testing domains that you mentioned. So I suppose there's a question, how did you find the confidence level between testing in the simulated environment to the mixed domain and then onto public roads? Was there a clear trace through in terms of confidence in those test results, and what were the findings from that?
Yeah, so it's a really, really good question. It's an excellent question. So there's a couple of different elements to that. One of the important elements is through correlation. So it's not included in this slide deck, but it's really important that we take these different modalities and we establish how a system under test, in simulation or in a proving ground test, performs for a given scenario, try and control as much as we can, and then see how the performance differs. If it's within a very similar envelope, then we can have a much greater confidence in the correlation. And if it's poor, well, then that's not necessarily, like a problem with the process. Rather, it allows us through that process to highlight, what we have as a simulation model is not correlating with how the vehicle actually acts in reality. So again, that's something else to say, we need to fix this, and we can help you.
Thank you.
No problem.
Awesome. Right, thank you again, Will.
Thank you very much, everybody.